Alright, so this is the chemistry lesson video for section 19.2, and this is part 2. So we're just going to wrap up, revisit some of these formulas, and then at the very end of the video we're going to briefly discuss neutralization reactions. That really comes out of section 19.4 in our book, but I just throw it in at the end of this because it's one slide, so it's not enough to make its own video. Alright, so acid-base indicators are special chemicals that change color as the pH of a solution changes. So if you look here, these are just a couple of different ones, like we have methyl red, universal, we have phenolphthalein down here. And so these are the pHs across the top, it goes 1 through 10. And so you can see how the colors change as the pH changes. Phenolphthalein is used a lot in something called a titration, where you need to look for neutralization because there is a clear change from clear to pink, a clear change, from colorless to pink. Whereas other ones, you know, like especially here, like how do you know when it's officially gotten from the reds to more of the blues? Because there's like this pinky purple kind of in the middle. Universal indicator is great because it kind of goes through the whole rainbow because it's a mixture of different substances. But the important thing about an acid-base indicator is it's going to be different in acidic than it is in basic. If it's the same color in both, that clearly indicates nothing. So let's knock out our section assessment, and again, the reason I split this video into two is just because the section assessment is mainly a review of a bunch of examples I showed you in the first video. So really, if you got those examples, maybe just fast forward to the end to watch that last part on neutralization reactions. So it says, what is the relationship between H plus and OH minus in an aqueous solution? Well, remember, because the product of the two always has to be the same number, as one goes up, the other goes down. So what is that relationship? That's an inverse relationship. So they're inversely proportional. Alright, number 2 says, what is true about the relative concentrations of the hydrogen ions and hydroxide ions in each kind of solution? Well, in a basic solution, remember, what makes a base? OH minus. So in a basic solution, your OH minus would be greater than your H plus. In acidic solution, remember acids produce H plus, so in an acidic solution, your H plus would be greater than your OH minus. And then remember, neutral is neither. It's not an acid or a base, and so in that case, your H plus equals your OH minus. And remember, it does not equal 0. Like, they don't equal 0. They equal 1 times 10 to the negative 7, which I know is a super tiny number, but it's not 0. Alright, so number 3, we're jumping back into some calculations. So I have the pH square on the next slide also, so I'm going to erase these answers as we kind of go back and forth. Alright, so for number 3, part A, it says determine the pH, so I'm looking for pH, of each solution. So for part A, our H plus equals 1 times 10 to the negative 6 molar. This is just my little cheat sheet down here, so I remember what I'm doing when I click over. Okay, so remember, we get our pH square out. We're looking for pH, so I'm going to put a question mark here. We have the H plus, so I'm going to follow this down arrow right here, and so I'll look, and there's my formula. So it tells me pH equals negative log of H plus. So I just plug in. So pH equals negative log of my H plus was 1 times 10 to the negative 6 molar. And so once I solve that, I get 6.00. Remember, pH and pOH have no units. H plus and OH minus have to have molarity. Alright, and so that's all you do for these. So maybe, especially if you were having trouble following the pH square in the first part of the video, maybe pause it and try the next couple on your own. Or watch me do another one and, you know, then try one. So maybe watch me do part B and then you can try C and D. Alright, so for part B, again, we're determining pH. So I'm looking for pH. But this time they gave me OH minus. They said OH minus is 1 times 10 to the negative 2 molar. Alright, so again, I'm going to go to my pH square. I'm looking for pH. So I'll put a question mark there. I know my OH minus. So again, you have two options. You can go across the top and down the side, which I don't recommend because this is the formula that most people plug in incorrectly, or you can go down the side and across the bottom. That's the direction I would recommend. So we're going to use that formula, and then we're going to use this formula. Okay, so we're going to go down the side first. So it tells me POH equals negative log of OH minus. So I plug in. So POH equals negative log of 1 times 10 to the negative 2 molar, and that gives me 2. But remember, this is POH. Like, we only made it here. We didn't go like this. We made it here. It has asked me for H+, so that's why I have to use a second formula. Okay, so I'm going to go across the bottom, so it tells me pH is 14 minus POH. So I just do 14 minus 12, and that gives me 2. And there's your answer. Alright, so see, the pH square makes it super easy, as long as you know how to use it. Alright, so let's look at a couple more. So remember, if you haven't tried any, pause it and try those last two on your own to make sure you can use the pH square. Alright, so I'll assume you've done that. So our next one, part C, says determine the pH. So again, we're looking for pH of a solution if H plus equals 3 zeros, 1, 2, 3, 1 molar. Alright, so let's go back to our pH square. So we don't know pH, so I'm looking for that. We do know H plus, so I have H plus. So again, this is just going to be a one-stepper. I'm going to follow this one formula going down. Alright, so my formula going down says pH equals negative log of H plus, so I just plug in. So pH equals negative log of 0.0001 molar. And so once I solve that, I end up getting 4 as my pH. Remember, no units. No units on pH and pOH. Alright, so hopefully you got that one right. So now let's try the last one. Or the last one on this question. There's still another question. Section assessment's kind of long. I just like to make sure you have plenty of examples. Alright, so it says determine the pH. So again, we're looking for pH of a solution with an OH minus of 1 times 10 to the negative 11. Okay, so let me go back to my pH square. So we're looking for pH. We have OH minus, so this is going to be another two-stepper. So remember, I would not recommend to go across the top unless you're good at putting things in the calculator. Alright, so what we're going to do is we're going to go down the side first and use this formula, and then go across the bottom and use this formula. Okay, so my going down the side formula says that POH equals negative log of OH minus. So I just plug in. So POH is negative log of 1 times 10 to the negative 11 molar. But remember, when you plug it in, POH has no units. So when you plug that in, you're going to get 11. But remember, that is the POH. We went here. We haven't gotten to pH yet. So then I have to go across the bottom. So it tells me pH is 14 minus POH. So then I just plug in. So pH is 14 minus 11, and that, of course, gives me 3. Now, again, I know some of you are probably like, oh my gosh, why are you writing all this out? Well, I have to write it all out. I'm the teacher. Okay, if you can do any of this just in your calculator or whatever, I'm just looking to make sure you can get the right answer. Okay, so you don't necessarily have to show all your calculator work. I will let you know if I need you to show work or not. Alright, so let's move on to the last question of the section assessment. So it says, what are the hydroxide ion concentrations for solutions with the following pH values? Okay, so again, this is something where I'll use my pH square because the question is the same for A, B, and C. The number just changes. I'm just going to write all 3 of them down and do them on the previous slide. Alright, so we're looking for OH minus, and they gave me a pH of 6, a pH of 9, and a pH of 12. Alright, so I'm going to go back to my square. So we're going to start with the pH of 6. So we don't know OH minus, so we're looking for that. We know pH is 6. Okay, so again, I would not recommend going across the top. I would recommend go across the bottom using this formula, and then go up the side using this formula. Again, going across the top works too. It's just that you're more likely to make a mistake. Alright, so I'm going to start at pH, so it tells me POH equals 14 minus pH. So POH is 14 minus, what are we doing this time? 6. So that gives me 8. But remember, that is my POH. They didn't ask me for POH. They asked me for OH minus. So I still need to go up. All right, so I'll follow my up formula. So it tells me OH minus is 10 raised to the negative, I just wrote negative pH, it's POH. And remember, this is 10 raised to the negative POH, not 10 minus POH. So I'll plug that in. I keep wanting to write H's for some reason. So my OH minus is 10 to the negative 8. And so when you put that in, of course, your calculator is just going to give you 1 times 10 to the negative 8. But what do we always have to put when we calculate H plus and OH minus, even though it's not given to us? The unit, which is molarity. Okay, so don't forget, H plus and OH minus have to have molarity. Okay, so remember, on your copy of your square, maybe you want to write molarity above both of them so that you can remember to do that. All right, so we just did pH of 6, so let's get rid of that one. Let's get rid of all my work. And then just notice we're going to follow the same path because we're still looking for OH minus, and they just gave me a different pH this time. This time the pH is 9. All right, so I'm going to start here. So it says POH equals 14 minus pH. So that means I'm going to do this time 14 minus, I'm going to do this one 9, which is 5. So now I have my POH, it is 5. So now I'm just going to go up. So it tells me OH minus is 10 to the negative POH. So I just say, okay, well, OH minus is 10 to the negative 5. Your calculator will most likely just give you 1 times 10 to the negative 5. And since I calculated OH minus, what do I have to remember? To put the molarity. All right. So if you haven't tried one of these on your own, maybe try the last one. So remember, the last one tells us that pH is 12. So just pause the video and try that last one, and then we'll look at it together. So I'll assume you've already tried it. Okay, so remember, we're following the same path. We're starting with pH, this time it's just 12, and we're working our way up to OH minus. So I follow my first formula that says POH equals 14 minus pH. So of course that just means 14 minus 12. A lot of you could do that step in your mind. So it gives me 2. So that's my POH. So now we need to go up to get OH minus. So OH minus is 10 raised to the negative POH. So OH minus is 10 to the negative 2. Most likely your calculator will probably end up changing it to 0.01, but putting 1 times 10 to the negative 2 is fine also. But what's the last thing you need? You calculated OH minus, so you gotta put, ooh, I'm running out of room, your molarity. All right, so like I said, the sooner you learn how to use the pH square, the easier your life will be on this section. Okay, but like I said, there's one thing we have to discuss for just a minute out of section 4, so I'm just going to throw that at the end of this video because it's literally one slide. So I didn't think there was any point in making a totally separate video on it. And that is neutralization reactions. So a neutralization reaction is a reaction between an acid and a base, and it forms water and a salt. So a salt is a compound formed from the cation of a base and the anion of an acid. So of course, when we think of salt, we automatically think of sodium chloride, which is a salt. But salt is a whole category of compounds. Okay, so I gave you 2 different examples here. Here's my acid, HCl, mixing with my base, NaOH. So the H and the OH, they make water, and what I'm left with is NaCl. So that makes our salt, which is the salt you think of when you think of salt anyway. However, the salt doesn't have to be NaCl. So here's a different acid. We have H2SO4, and we have a base, KOH. All right, so see, my acid has the H, my base has the OH. The H and the OH, they make water, and so what I'm left with is K and SO4, and so when those bond and make the ionic compound, it's considered a salt. All right, and so in neutralization reactions, sometimes you do need to balance it to make it make sense, so I balance that one, sometimes you don't. All right, but a neutralization reaction is just the mixture of an acid and a base until they cancel each other out and it makes a neutral solution. And like I said, that neutral solution is composed of water, which we know is neutral, and a salt.